Okay, I guess I'll just have to stay here and not move too much. I'll get started. So thanks everyone for being here. We wanted to take a little bit of time to show you a new open source library we are developing for both Kotlin, Scala, and many other languages. And this library is called SAF AI. And it's aimed to simplify the way you can integrate AI into your applications, services, and in general, how to use and interface with large language models for different applications. So we wanted to make this library extremely easy and be available in other languages. A little bit to the topic before, Scala has lost a bit of traction with ML in all those areas. We're trying to here contribute a little bit to one of the areas related to AI and machine learning. And this library is made by a lot of people, Sivia Functional and many other people in the open source community. It recently released. There is a team working in different language bindings, different aspects of the library, marketing, making sure the user experience is great. And if you are using any JVM language like Gradle with Scala or Java, we basically public our library in Maven Central. It's already available, so please do go ahead and check it out whenever you have a chance. It's the first alpha release, so expected to not be very stable. And at the moment, we have limited support for some LLM models, mostly the OpenAI and Hugging Face APIs. But we are currently building support for local models as well. So as I mentioned, it's originally available for Scala and Kotlin. And we are currently building bindings for other languages, Java, Rust, Go, Swift, and others to make it extremely easy to integrate AI in your backend services or whichever it is that you already have existing code. So the way you use this library is quite simple. You have this block called AI, and this AI block is like a function that is not evaluated. So purely functional programming with AI, if you call it. And once we open this block, this immediately gives us access to a context where we have a set of services and things that you can perform with different language models. So the first operation we can see here, prompt message, this is the simplest operation. Just ask the message to the language model. You get back a list of strings as a reply. And as we mentioned, because it's a function, we always need to say how we want to evaluate that workflow that we are doing with AI. And this is to prevent us from making mistakes, running into runtime errors that will crash our application in our server and so on. So in this particular case, this is the unsafe operator, get or throw, which basically tries to get the value of the monadic context of the AI. And if something fails for whatever reason, in this case, it will throw an exception. But there is also other alternatives. Like in this case, we can just call to either. This is an example from the Kotlin DSL, and we can evaluate our interaction with the AI and the language model by actually getting a typed error, which depending on the context, it can mean a set of different things. So as I mentioned, this is available for Kotlin, Scala, and other languages. So this would be the equivalent in a Scala. Looks fairly similar. Kotlin and Scala are not too far apart. And these are the set of different kinds of errors that we might find when we interact with an AI, or at least a subset of them. So for example, in some cases, we just get no responses. That seems fairly common, especially with certain APIs. In some other cases, we might get some JSON parsing errors, and this is related to how we handle the data back and forth from an AI. And in some other cases, we might be sending to the model large prompts that actually exceed the tokens or the limits of things that we can actually use to operate within the boundaries we set for a given model. So those kinds of errors are also contemplated by the typed API. One of the most interesting features of the library is that you can actually have the AI speak your modeling language. So you don't need to worry about how to manage the response of the AI and how does that fit in your mental model of what you're modeling. For example, here we are just using a simple model to represent what a movie it is in our application. It has a title, a genre, and a description. And we can see that when we call the AI function call, if we ask it for a prompt instead of a prompt message, this will trigger that the AI will go get its data, whether it's from its internal training or from external data sources that we can hook up to it. And then once the data is retrieved, it replies with the data in exactly the same format that you want to consume it in your data model. This helps you think about how you model your application, not so much how you have to interact with a large language model when consuming data. Another thing that is a little tiny feature of the library has this notion of prompt templates. It allows you to create these prompts with input and output variables, which you can chain together, much in the same fashion as you see if you're coming from Python with the LangChain library in Python. So there's like these kinds of utilities that help you organize and model your prompts and compose them together. In this particular case, we can just say, okay, here is a prompt with a topic variable, and there's an input variable that it expects we pass through. So whenever we're going to invoke the prompt, we can pass in the template, but also a map of keys to models that need to be replaced in the template whenever it's going to invoke the LLM. And most importantly, just calling the AI or the LLM that way as we did before is sometimes useless for certain problems because you just get predictions or hallucinations back from the model. It's a lot more useful when you provide a context, and with context we follow the same philosophy. You have this context function which you can pass in any kind of other function, like in this case search, and if search returns a list of strings, then you can make it part of the context. Additionally to this context, we also have more kind of like hardcore persistence storage where you can actually use type values to get and put in a context and then communicate with the AI. In this example, what we're doing is we're searching for the weather in a particular place. So this search function actually performs an internet search, which then brings some content into the memory of the execution block of the AI. And then whenever we ask the question, hey, knowing this forecast, what do you think I should wear? Then it can bring down from memory, from that context, the relevant documents based on similarity of the kind of question you're doing, and add those documents as prompt in the context to the AI so that it can more precisely solve the kind of problem that you're trying to achieve. And as we mentioned, because AIs are kind of monadic blocks that contain the context and the memory and dependencies, it also means that we can compose them together. So if we had two AI blocks like that one, and we fuse them or we execute another AI block within that one, then immediately inherits all of the context around it, much in the same way structured concurrency works in many languages. Besides the local context that I just showed you for the previous one, we have implementations where you can replace and plug and play other kinds of storages that are more capable than just a local memory. Like in this particular case, you can use the Lucene Apache index to store your vector stores and kind of information before you talk to the model. We also support PostgreSQL in the vector store. And we have other kinds of utilities for loading data and enhancing your context from different data sources. Like in this case, for example, here is a URL. This PDF URL belongs to a paper called The Tree of Thought that basically shows you how you can instruct an LLM to solve problems in much in the same way that a human does, like by backtracking, making other decisions once you prove one decision wasn't correct. So in this particular example, we can see that we have a context scope. We can invoke the PDF function with a given URL. Then we can go in an endless loop, like similar to what you will have in a CLI chat style input and output. So we're going to be asking questions about the actual book. We get some input from the user. Then we ask from the input to get an AI response, which is actually a custom model we have. And then we can print out whatever it is that the LLM returns given that context we provided, which is the PDF. So those lines of code that I show you on the left is basically what it takes for you to chat with PDFs or any other content that can be ingested as text. As I mentioned, AI are functions, so you can pass them around. You don't need to execute them in place. You could compose them and pass them as argument to your functions, to other programs. And whenever you're ready to execute them, you can just invoke one of the terminal operations like to either. And that gives you a type value contemplating both the result, but also the potential errors that may have arisen when communicating with AI. And extending this library is extremely simple. You can declare functions on the scope, or in the case of Kotlin, on the receiver scope of the AI scope. In the case of Scala, just with implicit. So this example in Scala would be using AI scope. And if we can see here, we are just using two custom models, original and summarized. And we can observe how the summarize function just calls prompt, and then it can get automatically the response from the AI in the type that you want to consume it with. Then once we open an AI block in our main program below, we can see that because the function is declared in the AI scope, then it has access to all of its contents. And if it was declared with implicits in Scala, then all the same. So there is a reason why we've been doing this Axivia function, not because just want to build a library for AI, because we're using this for our own work. We specialize in formal methods, formal verification, functional programming, and we're actually using AI in a hybrid fashion to solve some of these problems. Specifically, what we're doing is like when we go to a client and we have like a design phase for a system, we usually kind of spec out everything and how it should behave with a formal language like TLA Plus or Alloy that describes some of the most important parts of the system. But we are using AI to have it learn about this specification in such a way so that when we are analyzing code in our repositories, in our clients' repositories, we're able to run not only a static analysis tools that can inspect and find bugs in the code as the ones we have today, but we can also use the AI to summarize all of those problems found, propose solutions, attempt to create solutions for the code, which then get committed and prove if they fail or not, or if they follow the spec. And similarly, we are using the same notion or concept. We are creating and using this library to orchestrate different processes around stress testing, applications, source code in hand for bugs, etc. So that's about it. Just wanted to show you this little library that we released open source last week. We hope that you like it. We hope that if you like it, go and contribute or join us and provide feedback. And thank you for listening.
Okay, hello. Questions?
Hello. Thanks. It really looks amazing. And since one of my deepest desires to get rid of Python in my pipelines, I was wondering, what can you take at least for some of the pipeline types models from Hugging Face? Did I get it right?
So the first version that we released this week has support for OpenAI API and Hugging Face API from the point of view of HTTP communication. There is currently PRs in the repository. The following releases in a week or two, we are releasing support for local models, which means that you can load any model from Hugging Face. with a set of constraints on the format because it's not easy to load all PyTorch, Keras, and all of that specifically from the JVM. But we found a few solutions, so we are implementing this support, and it should be released in the next following weeks. So the goal is that this AI DSL, as you describe it, is not precisely tied to a specific model. You can tie it if you want. You can say this prompt in particular, I want it to be ChatGPT, and this other, I want it to be whatever else. But the idea is that you are creating these programs that are abstract, that are functions that are unevaluated, which then you can run in different potential runtimes. For example, test your program with ChatGPT versus Vicuna models, or you name it. So yeah, we are planning on building local support. We hope it's going to release soon.
Cool, thank you. And I'm very interested to know how exactly are you using Alloy. I didn't get it, but I'm very curious to chat about it.
In the case of Alloy, you mentioned?
Yes, at the end.
Okay. We internally use in the company Alloy to verify a state machine-like specification of your core system components. And we do have a Kotlin library, or a JVM library that you can use from Kotlin, Scala, or Java called Karat. This library allows you to use domain modeling like the one I show here today with an Alloy DSL. And then you can, it's a hybrid kind of model. You can combine both your models for your own purpose in your program, but you can symbolically run that piece of the software with Alloy to find all the error states or things that you didn't relate properly. So we are actually having the AI learn about Alloy and about all these tools. And once we run the tools statically, we have the AI go and try to provide fixes, recommendations, summaries, all kinds of stuff.
Right. More questions?
Hi, great talk. Could you elaborate on why you chose the monadic AI sort of nested DSL syntax instead of a more typical, dot notation, make a client call syntax?
Yes. So the biggest reason is that when you don't have some kind of context or wrapper or monadic syntax, then in direct style, those errors will be just exception for the most part. And that means that your application is gonna crash whenever, I don't know, the retries to OpenAI or some other problem that that is not expected happens. And while that is okay in a script in Python and in some systems where you are kind of like conscious about that, for the most part, this approach basically forces you to always deal with errors. And our approach and our contribution to AI is that we want it to be safer. So the known errors that we know that the AI can throw, either because of HTTP or because the model is consuming too much memory or things like that, then those we want somehow control. And of course, like if you don't care, you can always get or throw or alias that to an invoke and then YOLO with it. But by default, the library doesn't want you to make mistakes of that kind.
All right. Any other question?
Well, thank you so much. And if you have any other questions, I'll be around and during the conference and so on. Thank you.